All right, welcome back to The Explainer. Today, we are putting on our detective hats. We're going to dive into a really cool tool that medical detectives use to solve mysteries, and it's called the case control study. This is the go-to method for epidemiologists when they need to crack a case like yesterday.
So picture this. A brand new, kind of scary illness starts popping up all over a community. People are sick. Nobody knows why. The clock is ticking for public health officials, right? They don't have years to figure this out. They need clues, and they need them now. I mean, where do you even start?
Well, this is exactly where those disease detectives, we call them epidemiologists, step in. When some new health threat shows up, the pressure is on. You got to find the cause, and you got to do it fast so you can actually stop it.
Look, the usual way of doing this, following thousands of people for years and years just to see who gets sick, that's just not going to cut it. It's way too slow. So the key here is to flip the script. You have to work backwards. Instead of waiting for the future to happen, you dig into the past. Because think about it, the clues for what's making people sick today, they're not in the future. They're already there, hidden in the lives of the people who are sick right now.
So how do they do that? What's the tool that lets them look backwards so precisely? Well, it's the case control study. You can almost think of it as their special retroscope, a way to peer into the past to solve these medical puzzles. Okay, so what exactly is a case control study? It's a really clever kind of observational study. Basically, you start at the end of the story. You find a group of people who already have the disease. We call them the cases. Simple enough. Then you find another group of people who are really similar but who don't have the disease. These are your controls. And here's the magic part. You look back in time for both groups and you compare their pasts. You're hunting for that one key difference. What did the sick group do, or what were they exposed to that the healthy group wasn't? That difference, that could be your smoking gun.
The whole process is actually pretty straightforward. You can break it down into 3 simple steps. Step 1, find your cases, the folks who are sick. Step 2, select your controls, that all-important comparison group. And believe me, we're going to see in a minute just how crucial this step is. It's literally everything. And then step 3, you look back. You become a historian for both groups, digging into their pasts. You're asking questions like, hey, was this group more likely to have eaten at that one restaurant, or worked at that specific factory, or maybe taken this particular medicine?
All right, so let's talk about finding those cases and choosing those controls. Now, finding the cases, that's usually pretty easy. I mean, they're in hospitals, they're in clinics, but the real trick, the thing that can make or break your entire study, is picking the right controls.
And I'm not exaggerating here. A bad control group can send your entire investigation on a wild goose chase. Let me put it this way. Your controls have to be almost identical twins to your cases in every possible way. Age, gender, where they live, everything. With one giant exception, they don't have the disease. They need to be a perfect snapshot of the population that the cases came from. If you mess that up, you're going to fall into some serious traps.
So let's talk about the biggest, most famous trap of all. It's called selection bias. And what that means is the way you chose your controls actually created a fake link that isn't even real. This sounds tricky, so let's walk through a classic real-world example.
Okay, rewind to 1981. A huge study comes out and it sends shockwaves. Absolute panic through the public. The headline basically was that your daily cup of coffee might be linked to pancreatic cancer. Now, this is a really deadly disease, so you can imagine the media went wild and people were seriously freaking out.
And when you first looked at the data, it looked totally convincing. Check this out. You can see what's called a dose-response relationship. The more coffee people drank, the higher the risk seemed to be. Now, in epidemiology, a pattern like that is usually a huge red flag that you found something real. But there was a fatal flaw hiding in plain sight.
The problem, as you might have guessed, wasn't the cases, it was the controls. See, the researchers picked their control group from other patients in the same hospital, and a lot of these other patients had things like stomach ulcers or gastritis. So what's one of the first things a doctor tells you when you've got stomach problems? Lay off the coffee. This meant the control group was drinking way less coffee than the average person, not for any other reason than their other health issues. So, by comparison, the cancer patients looked like huge coffee drinkers. The whole link was a complete illusion, a ghost in the data created by that selection bias.
And this kind of mistake is not new, not at all. You can go all the way back to 1929 when a guy named Raymond Pearl did a study and made the same kind of error.
He chose hospital patients who had tuberculosis to be his controls, which you can imagine totally skewed his results. The lesson is timeless, really. You absolutely have to understand who your controls are.
Okay, so let's say you've picked the perfect control group. You've dodged the selection bias trap. You're not out of the woods yet, because there's another sneaky problem waiting for you. The trouble with human memory. This one's called recall bias.
So what is recall bias? It's when people who are sick remember their past differently than people who are healthy. And it's really important to get this. It's not because they're lying. It's just human nature. I mean, think about it. If you or someone you love gets really sick, you're going to search your memory. You're going to rack your brain for any possible reason why. You'll remember every little thing. A healthy person just doesn't have that same motivation to remember, so a lot of that stuff just fades away.
And here's maybe the most powerful and frankly heartbreaking example of this. Imagine a mother whose child is born with a serious birth defect. She is going to replay every single second of her pregnancy in her mind, right? Every cough, every pill she took, every weird thing she ate. Now compare that to a mother of a perfectly healthy baby. She just doesn't have a reason to do that same intense memory search. And that difference in how they remember, that alone can create a link between something in the past and the birth defect that isn't even real.
Let's put some numbers on this to see just how powerful this bias can be. Let's just pretend that the actual true rate of some mild infection during pregnancy is, say, 15%. Okay, that's the real number for all mothers. So in reality, there's no link at all between this little infection and any problems. Okay, but now let's ask them to remember if they had that infection. The mothers of the healthy kids, our controls, they might barely remember that little cold they had. Maybe only 1.5% of them even recall it. But the mothers of the sick children, our cases, they've been searching their memories. They remember everything. And maybe 9% of them report having that infection. And just like that, bam, your study shows a massive, terrifying link that is completely fake. That's how recall bias can literally create a phantom risk out of thin air.
So after all that, you might be wondering, with these huge, massive traps like selection bias and recall bias, why on earth would anyone still use these studies? And the answer is because for all its flaws, it's still an incredibly powerful and necessary tool. It really comes down to three huge advantages. First up, speed. You can get answers in months, not wait around for decades. Second, they're efficient, way cheaper than tracking thousands of people for years on end. And third, and this one is so important, they are perfect for studying rare diseases. Think about it. If a disease only hits one person in 100,000, how else could you possibly find enough sick people to study? A case control study lets you do exactly that.
So at the end of the day, you have to think of the case control study as a starting point. It's the best tool we have for coming up with a good guess, a hypothesis, really quickly when there's a new threat. And yeah, the traps are real, but a cleverly designed study, one that really thinks hard about avoiding them, can point us toward answers that literally save lives. And its strength, every single time, comes right back to that one thing, the brilliant, careful, clever choice of controls.
So here's the takeaway for you. The next time you see one of those scary headlines about a new study that links, your morning coffee or something to some terrible disease, you're now equipped to think like a real disease detective. Before you start to panic, just take a breath and ask yourself the single most important question. Okay, but who were the controls? Were they really the right comparison group? Because understanding that one question is the key to telling the difference between a real risk and just another statistical ghost. Thanks for joining me.